Hello there, folks. I have been developing C++ programs and as a hobby and as a professional, and I have since used Visual Studio IDE, and of course it only runs on Windows. I'm referring to the Visual Studio like 2019 or 2017, and I have used it since the Visual Studio 6 version, the old. And I have to say that mission critical C++ applications are most often usually developed in this IDE. The reason being is that C++ is a complex piece of program, and the support of the IDE to be able to step debug and examine memory variables, watch them in a very comfortable IDE setting is very critical in your analyzing of C++ code. None of this exists in other platforms. I have checked in YouTube the Lion, but I don't think it. I don't think. I think Lion is still not there yet. But lately, I have discovered, like we can see now, I am in Ubuntu, and I have tried to check the Visual Studio Code, which is the open source multi-platform light IDE. By the way, VScode or Visual Studio Code is not Visual Studio 2019. They're very different, like as a night and day. But nevertheless, I tried to give it a try. If how does it feel to develop C++ programs using VScode? So let us begin. So I have two C++ source codes here, which is main.cpp, and you can see I am linking to a Google test framework to automatically execute pieces of code, and this is also a file, so which also contains Google test cases. But our main entry point is in this one, right? And we have a CMake, which is of course a different beast on its own right. Okay, so these lines here are just I copied and paste them, and if you're still not aware of it, the recommended way to use Google Test C++ framework is to compile it from source along with your program and to not use it as a library. You can read that in the Google Test FAQ. Today I also discovered that there is a nice way of CMake support for Google Test, wherein you can do it like this, add some configuration. By the way, we are referring to the CMake list.txt.in, and there's a folder here. It will be automatically created, and if we examine the CMake list.txt.in, this is the content. So what this do is that it will download from GitHub the Google test and compile it locally together with your code. First, we will do it without VScode, and then we will do it with VScode. Okay. So without VScode, of course, we know that the CMake way of doing things is to create a build folder, then run CMake. And as you can see, the CMake auto download the Google test source code remotely and build it as part of our application here. As you can see, the lib folder is still empty. Then if we run the build command, it will build the Google test along with our application. And now if we do ls, we should be seeing our application here, which is this main. And if we run it, and you can see that it's running the test cases and printing all the messages that we put in our source code. Alright, so and this alone is very nice because because CMake is auto downloading Google Test for us and building it with our application. No more hassle to manually copy the source code. Now let us delete this folder, build, and now let us use VScode. Now that we are in this folder, we have to run the VScode executable and a dot. We have to tell VScode the current root directory. And now VScode has opened our and seems to be intelligent enough to. Okay, I will click allow. So auto, like, it's been doing a lot of things. Like this VScode is nice, like, and it also has a command line shell here. And if we do an ls, and we can see that our build folder is, I mean, VScode did all of this, except that there's some gotchas. The lib is empty. So if I run the build task in the menu, okay, let's give it. It will complain that it could not find the gtest debug version, which I specified in task. And you can see that here you have to add all the source files manually. By the way, these are manual things that you need to do. These files are in the, if you they are hidden in a VScode folder. So this file cpp properties JSON, which is this one, I manually specified this path so that there will be no squiggly oh, there's a squiggly. Yeah, but let us try to build this first. Somehow I still find the need to manually build it in the command line before the IDE to be fully operational. Now the library is there, and if I do the build here, build task, it should succeed now, and we can step debug. Okay, you'll notice that let us just let me close it again and open it again. It's still very rough around the edges, but so as you can see, the squiggly line disappeared. So okay, still not build Google test src. But I don't know why the squiggly line is still there. Anyway, let us now put a breakpoint. Now I put a breakpoint here in one of my Google tests, and let me now run F5. And it's very nice that we now have a decent IDE in the Linux platform to debug C++. Very nice, even though it's not yet that solid, but I have my F10 keys. Now we have a buffer, 8 and we put random bytes into that buffer. Say that we want to examine the contents of the buffer. All we have is this one. Now this is what I'm saying. In Visual Studio IDE, the professional version of the IDE, all of this is in the IDE first class. But because VScode is just a poor man's IDE, then there's a workaround here. If you go to the debug console and you copy the memory address of the buffer, copy value and type xx at 8xb and address. Since this is just on top of GDB, then we can see the B7E46D 183.228.189. If we print that, okay, let's open a terminal. So 183.228. So B7E4BD and B7E4BD and B7E4 6D. Okay, 109. Sorry, 6D, and we have a match. So this is how we do it, and in here very primitive, but it's nice because this is already Linux, and I don't think any other IDE can do it like this. I mean, I don't know, but this is already nice. Like, we can step debug and we can see maybe we can see the output here. And finish the program. So, not bad in my opinion. And the nice thing with VS Code is this is a multi-language IDE. And in fact, I even have Haskell in here. Go on Haskell. I have Golang, Kotlin, Python, Java, C Sharp, Rust, Lua. For example, let us load the Lua app and press F5, and we can step debug in Lua. Hallelujah. How about Haskell? Let's try Haskell. Alright, so we have Haskell. It has its main entry point, some func. Let's try to put a breakpoint in some func, okay? And let's try to debug. F5. Come on. Wow. So see, it hit the breakpoint. So how could you find an IDE that has multi-language support? This is very cool. And close folder. Let's go to Golang and press F5. And F11. This is Golang. So one IDE to rule them all. It may not be the best in a specific in C++, but this IDE is multi-talented. Like, let's go to Rust. I even have a Rust here. Like, no other IDE can do this, I think. So I'm very surprised that this light VScode is so it's like a jack of all trades, and the benefit of this is now you can now you can synthesize the syntax of different languages, because we have one IDE to practice all of this. Like, declare an array in Rust and do it the same for all of the languages. Create a for loop in Rust and create a for loop in all of the languages. That's the concept, and we can have a big picture of the entire landscape. Let's go to the C Sharp. There's even Kotlin here, Java. Like, okay, let's close this. My version, by the way, is this one. So, like I said, I underestimated VS Code for a long time now, but I think this might be my favorite IDE, my hobbyist IDE, starting today, because of what I just found out today. Of course, in a professional C++, I will still use Visual Studio 2019 for mission critical C++ code, but for hobbyist C++, solving puzzles and checking syntax, VScode is a very light alternative that may not be the best, may not be mission critical, but it does the job. I hope forward to seeing more improvements from this tool.